In this second video, we're going to start looking at algebra. We're going to start with the topic of simplifying expressions. So, for example, if we were asked to simplify 4p minus 2q plus 3p plus 5q, we would do this by collecting like terms. The p's are like terms and the q's are like terms. The way I like to do this, if you're unsure, is just to go ahead and put boxes around them. I've got positive 4p and positive 3p. If I then put circles around the terms in Q, I can see that I've got minus 2q plus 5q. So if I want to simplify this expression, and an expression is just a collection now of algebraic terms, all I'm going to do is take the p's. I've got 4p plus 3p, that's going to give me 7p. I've got minus 2q plus 5q, that's going to give me plus 3q. A common error is that people add this 2q to the 5q. So it's 7p plus 3q. And this now is simplified. I've collected like terms. So let's do a slightly more challenging one. I've got minus 2x plus 4y minus 3x plus x plus y minus 6. So we're going to go ahead and collect like terms. So again, using now the squares and circles, I've got minus 2x minus 3x plus an x. And then if we look at terms in y, we've got plus 4y, we've got plus 1y, and then we have this minus 6 at the end. This is just a number, or what we call a constant. Let's just put something that we can see around that one. Let's go for, in fact, I'll just put a bubble around that one. So all I'm going to do is put that around. So that's minus 6. Okay, so let's go ahead and do this. So what we can do now is the following. Minus 2x minus 3x plus an x. Well, minus 2x minus another 3x gives me minus 5x plus 1x. That's going to give me minus 4x. I've got plus 4y plus another y. That's going to be plus 5y. And then we simply subtract 6. So I'm collecting like terms. One more. If we have x squared plus 2x minus y minus 3y minus 2x squared, we can collect like terms. Now, x squared and x are not like terms. So, for example, if x was equal to 4, then x squared would be equal to 16, as it would be 4 times 4. So I'm going to collect the like terms, and just doing this, let's go ahead and do that. So I've got plus x squared. I know it's plus because there's no sign in front of it to tell me otherwise. I've got minus 2x squared. I've got now the plus 2x, and I'm just going to put that there. Then I've got minus y minus another 3y. So let's just put these around here. You certainly don't have to do this, but to begin with, it might help you avoid making errors with the signs. So x squared minus 2x squared is going to give me minus 1 lot of x squared. So we just write minus x squared. I've got plus 2x, and then I've got minus y minus another 3y. That's minus 4y. So I've fully simplified this by collecting like terms. Okay, let's move on and look at the next one. Right, I've put this one here, x times x. This is a big pet hate of mine. X times x is not 2x. Okay, we can see this. So x multiplied, and when we write the x in algebra, it's a curly x. This is equal to x squared. Now, just think about this. If x was equal to 3, then taking this number, 3 multiplied by 3 is 9. It's not 2 times by 3, which is 6. This is incorrect. X times x is x squared. If you want to look at that now, let's say we had a square, and this was a square, and we had a side length of 3. The area is going to be now 3 times by 3, which is 9. So if I replace this now with an x and an x, the area of this square is going to be x squared. It's not going to be 2x. The perimeter, if you're interested, would be 4x. X plus x plus x plus x is 4x. So don't fall into that trap. Now, if we were asked, for example, now to simplify y multiplied by y multiplied by y, this is going to give us y to the power of 3. It's not 3y. So if you think, for example, now, let's say that y was 2. So 2 times by 2 times by 2, this gives us now, 2 times 2 is 4, times by 2, this gives us 8. It doesn't give us now 3 lots of 2, which is 6. Okay, so that's a nice straightforward example. Now, if we had y plus y plus y plus y, this would give us 4y. Again, we're just adding. Take a number for y and just try it out. So, for example, now, if y was equal to 1, then 1 plus 1 plus 1 plus 1 is just going to be 4 lots of 1. It's not now y to the power of 4. So don't fall into that trap. So let's do a slightly harder one. Let's do now the following. Let's say we've got 2p multiplied by p multiplied by p. I'm going to have now p to the power of 3 multiplied by 2, which will be 2p to the power of 3, or 2p cubed. Okay, let's now look at some powers. Okay, when we have the base, which is going to be, and we can take anything, let's take the base to be a. If we have a to the power of m, and we multiply it by a to the power of n, we simply add the powers. Now this seems quite formal, but it makes sense. So if I have now, let's say we've got 2 to the power of 3, multiplied by 2 to the power of 2, this is going to give me 2 to the power of 3 plus 2, which is 5. So when we're multiplying, the bases are the same, we add the powers. Now if we think about this, 2 to the power of 3 is going to be 8, 2 to the power of 2 is going to be 4, and 8 times by 4 is 32, and 2 to the power of 5 is 32. So these are what we call the rules of indices. We're just taking now a base, and a base is just a number. Or we could have now what we call a variable. We just add the powers. So let's try one more. Let's try 3 squared multiplied by 3 to the power of 7. This is going to give me 3 to the power of 2 plus 7, which is 3 to the power of 9. Don't fall into a trap of writing now 9 to the power of 9. So they are the rules of indices. Now in the last video we looked at what this actually meant in terms of the power. If we have, and I'll just jot it down here so we can do some more here. If we have now 4 to the power of 3, the number that I need to multiply is 4, and I need 3 of them. So if you want to think about it like so, these are the powers that we looked at in number. 4 is the number I'm multiplying, and I need 3 of them. 4 times by 4 is 16. If we multiply 16 by 4, this is going to give us 64. A common error is to write 12. It's not 12. 4 times by 3 is not the same as 4 to the power of 3. So if I look now at 5 squared, this is telling me I need to multiply 5 by 5. 5 is the number that I'm multiplying, and I need 2 of them, and that gives me 25. 2 to the power of 4. Pet hate. Often students write that this is 8. It's 2 times by 2 times by 2 times by 2. 2 times 2 is going to give me 4. Times that by 2, it gives me 8. Times that by 2, it gives me 16. So that's just recapping slightly from where we were before. So back to the rules of indices. Let's now look at the next one. A to the power of m divided by a to the power of n is a to the power of m minus n. Again, very formal. If we're multiplying, we add the powers. If we're dividing, we subtract the powers. So let's say I've got now 3 to the power of 6 divided by 3 to the power of 2. This is going to be 3 to the power of 4. If I have x to the power of 7 divided by x to the power of 5, this will be x to the power of 7 minus 5, which is x squared. So all we're looking at now are the rules of indices. Don't get caught up with the formal definition. Just remember, if you're multiplying and the bases are the same, this is the base here, in this case 2 is the base, then you add the powers. If you're dividing and the base is the same, in this case x, you subtract the powers. Just to complete this, I'm just going to give you now that x to the power of 0 is 1. Anything to the power of 0 is 1. 3 to the power of 0 is 1. 5 to the power of 0 is equal to 1. So that's just an additional bit. Now whether that will come up in an exam is entirely up to whether the exam board feel that it's useful or not. But certainly if you're going on to higher, it's something that you will need to know. So the rules of indices or working with powers. Okay, so let's now tick off what we've done. So we've looked at simplifying expressions. We've looked now at multiplying, and we've looked at powers. Okay, let's move on now to the section on solving equations. What we're going to do is work through a range of different equations and look at solving them. I like to be very consistent in my approach with this. So let's start with something that's really straightforward. This is an equation. 2x is equal to 4. The difference between an equation and an expression is that an equation will have an equal sign in it. So equation means equals. So for example now, 2x plus 3y is an expression. 2x is equal to 4 is an equation. Right, at this stage you can probably tell that the answer is 2. When I'm solving equations, I like to now keep the same method each time. So what we're going to do with this particular one is undo the equation. And what I'm going to say to myself is that I'm going to divide both sides of this equation by 2. So if I divide both sides of this equation by 2, instead of having 2x, I'm going to have 1x. That is what I'm looking to do. I'm looking to find the value of this unknown number. So I can say now if I divide both sides of the equation by 2, I'm doing the same thing, therefore it will hold true. And x is going to be equal to 2. Whenever you're solving an equation, do check that it works and check that you can feed this back in and that it will give you the correct answer. 2 lots of 2 is going to be 4. Now often people are scared, they're algebra phobes if you like. What I'd like to think about now is if you want to avoid getting worked up on this, what I'm going to do is put a box here. 2 of something in this box is going to be equal to 4. So all I'm doing now is writing, instead of x, this horrible thing here, 2 of something is equal to 4. What do I need to put in here to make this correct? Even if you want to write 2 times something, well, whatever's in that box is going to be now 4 divided by 2. So if you want to look at it in that way, whatever's in this box now, some number. X is just a number that we're trying to find. That number is going to be 4 divided by 2. We're doing the opposite. Okay, so let's look at another one. Let's say we've got now that 3x is equal to 12. I'm going to divide both sides of this equation by 3. So x is going to be equal to 12 over 3. And that gives me that x is equal to 4. I'm simply doing the opposite. This number was multiplied by 3 to give 12. Therefore, if we want that number, we're going to divide by 3. And that is, of course, dividing both sides of the equation. And the reason that I say that is now if we have, for example, x over 5 is equal to 2, then this time we're going to multiply both sides of the equation by 5. X, this number we started with, was divided by 5, so I need to multiply both sides to find out what that was, and that would give me now 5 times by 2, and that would give us x is equal to 10. Now that's absolutely blindingly obvious when we put 10 in here. 10 divided by 5 is 2. So be consistent, as when these get slightly harder, doing it step by step will help. Okay, so let's look at another one. Let's say we've got now 2x minus 1 is equal to 5. And we want to solve this equation to find the value of the unknown. The unknown is x. Often we call it an unknown or a variable. Often students work backwards. I personally don't like to work backwards. I like to do now the same to each side of the equation. I like to balance the equation. There's also this idea of changing sides and changing signs. I might look at that as I go through, but I personally like to balance an equation. Now, if you think about this as a set of weighing scales, what we have is two lots of this number we're trying to find out, minus 1 is equal to 5. What I want to do now is isolate first the 2x and then find the value of x. So essentially, I'm going to now undo this. So my first move is to add 1 to both sides of this equation. What I do to one side, I must do to the other. So if I add 1 here, this will now essentially cancel this 1. So I'm left now with 2x is equal to 5 plus 1, which is 6. At this stage, I'm going to divide both sides of the equation by 2. And just showing my work in here, step by step, if you can get into this habit, it will help you solve harder equations. So x is going to be equal to 6 divided by 2, and x is equal to 3. So does that make sense? Well, 2 lots of 3 is 6, minus 1 is equal to 5. And you might say to yourself, well, that's slightly long-winded. But certainly when we have variables or unknowns on both sides of the equation, this can really help. Okay, so let's look at another example. Now, we could have, let's do a flip of this one. What we might have now is x over 4 minus 1 is going to be equal to 6. So I first want to isolate x over 4. So I'm going to add 1 to both sides of the equation. So just showing, and this is good to write in your books, especially if you're going to be revising. If I add 1 to this side of the equation, I'm going to end up with 0. If I add 1 here, we're going to end up with 7. Now, at this stage, I'm going to do the opposite, which is multiply both sides of the equation by 4. If I multiply both sides of the equation by 4, I'm going to have x is equal to 7 times by 4, so x would be equal to 28. And that is my final answer. Just think about this now. If I multiply x divided by 4, that's just going to give me x. If I multiply 7 by 4, we get 28. So this is fairly reasonable, fairly logical. So let's try another example. Let's go for something slightly harder. Let's go for minus 3x plus 6 is going to be equal to, and we will go on this one for minus 9. Okay, now with this one, what we can do is just do a bit of rearranging. You can solve this straightforward as you like. What I'm going to do now is the following. I'm going to add 3x to both sides of the equation. So adding 3x to both sides. That's going to mean that I don't have negative 3x. You certainly can leave it as negative 3x, but then at the end we'd have to divide through by minus 3. So what I'm left with now is that 6 will be equal to, adding 3x to both sides, 3x minus 9. So all I've done is just added the 3x to both sides. I'm now going to add 9 to both sides of the equation. Now this 9 is not 9x, in the same way this 6 is not 6x. These now are different. The x's are not just the same as the numbers. So adding 9 to both sides, we're going to have that 6 plus 9 is 15. 15 is equal to 3x. Now don't be worried that the 3x is on the right hand side of the equation rather than the left hand side. It really doesn't matter. We could write that 3x is equal to 15 like so. So at this stage I'm simply wanting to find one lot of x, so I'm going to divide both sides of the equation by 3. So if I divide both sides of the equation by 3, 15 divided by 3 is going to give me 5, and we can see that x, the number we're looking for, the unknown, is going to be 5. Of course, what you could have done at this stage, and I'll show you here, if we had started this again, we could have subtracted 6 from both sides of the equation here, and that would have given me that minus 3x is equal to minus 15. Then we would have divided both sides by minus 3. Minus 15 over minus 3. From our work on number, we saw that dividing two negative numbers gave us a positive number, and we could see that x is equal to 5. If you're taking your maths on, you might want to look at it this way, as it's something that you will need to be comfortable with. Okay, so these are solving equations when we have an unknown on one side. We might have other times when we've got unknowns on both sides. So let's look at an example. 2x plus 3 is equal to x plus 10. So I've got an unknown on both sides. The unknown in this case is x. We're trying to solve for x. What I'd like to do is collect the x's on one side and the numbers on the other side. So my first move here is to subtract 1x from both sides. If I subtract 1x from both sides, that will mean that the right hand side of this equation will no longer have a term in x. So if I take x off both sides, I'll be left with x plus 3 is going to be equal to 10. So 2x minus an x is just 1x. X minus x is 0. I'm now going to subtract 3 from both sides of the equation to isolate now the term in x. If I do that, x will be equal to 7, and we solve that equation. So let's look at 2 lots of 7 is 14, plus 3, that gives me 17. Does that equal 7 plus 10? Yes, it does. So we can see that this is the correct number. Okay, let's look at a slightly harder one. Let's say we have now 4x plus, and we'll go for plus 6, is equal now to 2x plus 10. Okay, at this stage now, I've got unknowns on both sides. 4x on this side, 2x on this side. Generally, I work on the side with the largest value of x's, which is this side. So what I'm going to do now, I want x's on one side, numbers on the other side. I'm going to subtract 2x from both sides of the equation. If I do this, that will now give me no terms in x on the right hand side of the equation. So if I take 2x off here, I've got now 2x plus 6. If I take 2x off here, I've got 10. I've not got 6x here. This is just 6 and this is just 10. This is what we call a constant or a number. This is an unknown or a variable. They are different. At this stage, I want 2x by itself, so I'm going to do the opposite, or if you like, the inverse of adding 6, which is subtracting 6 from both sides of the equation. So that's going to just leave me on the left hand side 2x. If I subtract 6 from 10, that gives me 4. I'm now going to divide both sides of the equation by 2 to find the value of 1x. That is what we set out to do, and we can see that x is going to be equal to 2. So that gives me my final answer. X is equal to 2, and we've done this step by step. Often you'll be awarded 2 to 3 marks, and you will need to show workings. Okay, let's try a much more challenging one. So what we're going to have then is the following. We're going to have now 3x minus 7 is equal to minus 5x minus 1. We want to solve for x. Now I'm looking at this thinking to myself, I've got more x's here. I haven't though, because I've got minus 5x. What I'm going to do here is plus 5x to both sides of this equation. If I add 5x to this side, minus 5x plus 5x is going to give me 0. Adding 5x to this side, we have 8x minus the 7 is equal to minus 1. So at this stage, I've now simply got the x's on one side. I need to get the numbers on the other side. So I'm going to add 7 to both sides of the equation. If I add 7 to this side, minus 7 plus 7 will get rid of that. If I add 7 to the other side now, we will have 8x is equal to minus 1 plus 7, which gives us 6. At this stage, I'm going to divide both sides of the equation by 8. 8 lots of this number is 6. If I want one lot of a number, I need to divide both sides of the equation by 8. The shock horror comes here, and we don't have a whole number. We have a fraction. This is not an integer. Don't be worried, often they're not. It's just a case now of some equations won't give you whole numbers. We can simplify this and write this as 3/4. So all I've done is simplify the fraction. We can divide numerator and denominator by 2, which is what we looked at in the last video. So don't worry now that your answer isn't an integer. It's simply a case now that some equations won't give you that. If you want to check in your calculator, 3 lots of 3/4 minus 7 will be equal to minus 5 lots of 3/4 minus 1. Just be confident, and this is why I like the step-by-step approach rather than trying to work things backwards. So for example, on this one, students are often learn that they add 1 and divide by 2. Now, when we've got unknowns on both sides, it can be a nightmare trying to do it that way. Okay, so that's solving equations. I'm going to come back to solving equations later on when we have brackets. For now though, what we're going to do is just tick these off. So we've solved equations, and we've solved equations with unknowns on both sides. Let's move on to factoring. Factoring is like Christmas. You're wrapping up a present. So let's take an algebraic expression. 2x plus 4. This is an expression. It's not an equation as there's no equal sign. We might be asked to factor this. Now, if we want to factor this, what we're looking to do is take out common factors, and that will be the highest common factor. So let's start now with the numbers. So what's the biggest number or the highest common factor that will go into 2 and 4? The answer is 2. I don't have an x on both of my terms, therefore it's not common. I'm now going to set up a bracket. You can now ask yourself at this stage, what do I need to multiply 2 by to get 2x? The answer is x. What do I need to multiply 2 by to get positive 4? The answer is plus 2. Alternatively, you could say, what is 2x divided by 2? That gives you x. What is plus 4 divided by 2? That's plus 2. So this is what we call factoring. It's putting into a set of brackets. When we go on to expanding, we can go ahead and check this. Expanding is the opposite, it's multiplying amount, or if you want the Christmas analogy, it's unwrapping the presents. So let's look at now 5y minus 10. So let's start with the numbers. What's the biggest number that goes into both 5 and 10? The answer is 5. Y is not common to both terms, so we can't take it out as a common factor. What do I need to multiply y by to get 5, or what do I need to multiply 5 by to get 5y? The answer is y. What do I need to multiply 5 by to get minus 10? The answer is minus 2. Be careful on these. Okay, let's look at a slightly harder one. Let's look at 15x squared plus 10x. Now, we've got 15 and 10. What's the highest common factor of 15 and 10? It's the biggest number that goes into both. That is going to be 5. I've got x squared and x. If you like, x squared is x multiplied by x, and we have now x as a single power here. So I can see that I can take now x to the first power out. I'm now going to open up the brackets. Remember, x squared is x times x. I've got 1 here and 1 here. 1 is common to both of these terms. So what do I need to multiply 5x by to get 15x squared? Well, I know that I need to multiply 5 by 3 to get 15, and I know that I need to multiply x by x to get x squared. So we have now 5x on the outside. This is common to both, 3x. What do I need to multiply 5x to get plus 10x? The answer is plus 2. No more x's are required. If I had another x, this would become x squared when we multiplied it out. And of course, we will look at expanding very shortly. I suppose you could argue now that it's probably easier to understand expanding before factoring. It's just the way that I've printed this up. So hopefully when we go back, it will make some sense. Okay, let's look at a very tough example. Let's say we have now 6x squared plus 2x cubed, and then we have minus 8. Okay, so let's have a look at what we've got. In fact, we'll have minus 8x. Let's make this really tough. We've got 6, 2 and 8. The biggest number that goes into 6, 2 and 8 is going to be 2. We've got x squared, x cubed and x. So if we look at x squared is equal to x multiplied by x. If we look at x cubed, this is x multiplied by x multiplied by x. And x, of course, is just x. We can see that x is common to all of these. We can't have x squared, as we've got now no other x here. So x is going to be common. What do I need to multiply 2x by to get 6x squared? The answer is 3x. What do I need to multiply 2x by to get 2x cubed? The answer is x squared. Just think about this as a 1. X times by x squared is x cubed. What do I need to multiply 2x by to get minus 8x? The answer is minus 4. So quite a challenging example. So when we're factoring, we're taking the highest common factor of numbers and letters outside the bracket, and then we're going ahead and simply working out what we need to multiply by. So you can see it now as the division, or you can see it as multiplication. So that's factoring. Factoring is putting back into a set of brackets. So let's go ahead now and look at expanding. Expanding is the opposite. So what I'm going to do is start just here. Let's go ahead and expand now 2 lots of this quantity. Now you might be asked to expand, multiply out or simplify. All we do is multiply everything on the outside by the inside. So if I have 2 lots of x, that's going to be equal to 2x. If I have 2 lots now of plus 2, that's going to be plus 4. And we know that anyway. All I'm doing is simply multiplying it out. So if we were asked to expand and simplify, or expand or simplify, what we're going to have on this one is 5 lots of y, and then we're going to have 5 lots of minus 2, which is minus 10. We're multiplying everything on the outside by the inside. So here we would now multiply the 5x by the 3x. 5 times by 3 is 15. X times by x is x squared. Then we do the 5x multiplied by positive 2. 5 times by 2 is going to give me the 10, and then we're going to have 1x. So let's look at expanding some brackets. What we're going to have then is the following. We're going to have now 4, and then we'll have p minus 3. So everything on the outside by the inside. This is going to give me now 4p minus 4 times by 3, which is going to give me minus 12. Okay, let's look at another one. Let's look at 2x, and then we're going to have 4 plus x. So if I multiply 2x by 4, 2 times by 4 is going to give me 8, so we're going to have 8x. 2x multiplied by x is going to give me now plus 2x squared. So all we're doing is multiplying this out, we're expanding it. Okay, let's have a look at a nasty one. Let's do minus 3x, and we're going to have now x squared minus 4. Okay, so if I multiply it now, I've got minus 3. Minus 3 times by this imaginary one, or invisible one I should say, is minus 3. So we know we're going to get minus 3. X times by x squared is x cubed. Now I've got minus 3x multiplied by minus 4. We're multiplying two negatives. That's going to give me a positive. So I can say this will be plus 12x. And that now is expanded. So a lot more challenge in this one. We'll do one more. Let's say we've got now 5p. We're going to have minus 2p. And then let's say plus 3y. So let's go ahead and do this one. So this one, 5 times by 2 is going to be 10. We've got a positive and a negative, so that's going to be minus 10. P times by p is p squared. 5 times by 3 is going to give me 15. We can see it's going to be positive. And then p times by y is just py. If we go back to some basics with this p and y, if we had, for example, let's say we had 5x multiplied by, let's multiply this by 10y, well, this is going to give me now 5 times by 10, which is going to give me 50. Then we're going to have xy. Just think now that if x was going to be equal to 1 and y was going to be equal to 2, this would just be doing 5 times by 1 times by 10 times by 2. And remember, with algebra, if we write it in this form and there's no signs between it, it means that we multiply. So for example now, if I said 2 lots of 3, this now is the same as 2 times by 3, which of course gives us 6. So if I said now 10xy, this means 10 times x times by y. Let's just do one more of these. Let's say we've got now 4pq multiplied by 2p. 4 times by 2 is 8. P times by p is going to be p squared, and then we're just going to have the q. If we had now, for example here, q squared, this would be exactly the same, 8p squared, but then we'd have q cubed. And it's quite a toughie to say that. Okay, so that's looking at now at factoring and expanding. Factoring is putting back into brackets, expanding is doing the opposite. Okay, I'm going to look at this one very shortly, but for now I want to bring back equations, this time with brackets in them. So we looked at solving equations, we're now going to look at solving equations with brackets in. So what I'm going to have then is the following. I'm going to have 2 lots of x plus 4 is equal to, let's just say, now we'll go for 6. At this stage, you could divide both sides of this equation by 2. I'm not too fussed if you don't do that. What we're going to do, though, is solve for x. We want to know what x is going to be. So what I'm going to do is 2 times by x and 2 times by positive 4. So we're going to expand the brackets. That's going to give me 2x plus 8 is equal to 6. I'm now going to subtract 8 from both sides. So 2x is going to be 6 minus 8, which gives us minus 2. And then we're going to divide both sides now by 2. X is going to be equal to minus 1. So that now gives me my answer. Now, does that work? Well, if we put minus 1 in, minus 1 plus 4 is 3. 2 times by 3 is 6. So we know that's the correct answer. Let's look at a slightly more challenging one. 3, and then we're going to have 2x minus 1 is equal to 4, and then we're going to have on here x plus 6. So let's see what we get from this one. So if we expand the brackets, 3 lots of 2x is 6x. 3 lots of minus 1 is minus 3. Often students put here now minus 1 or plus 3. Just be careful, just expand it out. That's going to be equal to 4x plus 24. Okay, I've got 6x on this side, 4x on this side, so I'm going to subtract 4x from both sides. Remember, we're going back to solving. We want the x's on one side, numbers on the other. That's going to give me 2x minus 3 is equal to 24. I'm now going to do the opposite and add 3 to both sides, so 2x is going to be equal to 27. I'm now going to divide both sides of the equation by 2, so x is going to be equal to 27 over 2. If you want, you could write that is x is equal to 13.5, or you can leave it as what we call an exact fraction. Don't worry that it hasn't come up to be an integer value. That's a whole number. So let's just check. Let's see if this works. If you're unsure, let's grab up a calculator. So let's put in here. Now you can, in your calculator, you can put now 27 over 2. So 27 over 2, as you can see, when we press this button, yesterday it's 13.5. So what I'm going to do is write in now the following. We're going to look at 3 lots now of 2 lots of my answer. I've put it in as my answer, minus 1. And that will give me now 78. Okay, so over here we would have 78. Let's see what happens if I put this number in here. So back with the calculator, and I'm going to put in, and I'll put it as a fraction this time, 4 lots of now the answer, which is going to be 27 over 2, or if you like 13.5. Then we're going to add to this 6. What does that give me? That gives me 78. Therefore, that is the correct answer to the equation. So that's what we've done. We've simply now subbed it in and found the value. This is about the hardest question that you would possibly get on a foundation paper in terms of solving an equation. If you do it methodically, as we did before, step by step, doing the inverse, then you'll get your answer. Okay, I'm going to include the next bit. Sometimes it's not on foundation, but it's worth looking at anyway. So we've done our factoring and expanding. We've now looked at solving equations with unknowns on both sides and brackets in, which is putting lots of different skills together. Let's look at expanding double brackets. So what we're going to do is take a set of double brackets. Double brackets, we might have, for example, x plus 4 multiplied by x plus 2. The way I like to do this is something called FOIL. First, outer, inner, last. You certainly don't have to do it that way, and often this is taught using a grid. I prefer FOIL, first, outer, inner, last, but it really doesn't matter. So the first one is going to be, now let's put it here, the first one is x times by x. You're simply multiplying each of these by one another. So x times by x is x squared. So this is going to give me now x squared. If I do the outer terms in the brackets, it's going to give me now the x multiplied by positive 2, so that's going to be plus 2x. So if I put this here, that's going to be plus 2x. If I now look at the inner terms, and when I'm talking about inner, we're talking about these ones. So I've got plus 4 times by x, that's going to be plus 4x. and just jotting this here, so 4x. And then the last term is going to give me now positive 4 multiplied by positive 2, which is going to give me plus 8. Often students add these. It doesn't become 6, it becomes 8. So all of these terms are positive. All we need to do at this stage is just tidy up by collecting like terms. Remember, like terms in this case are the terms in x. So x squared plus 6x plus 8. And that now is expanding a set of double brackets. Let's try x plus 1 and then x minus 3. So this time we have a negative. The first term, x times by x is x squared. Outer, I'm going to do x multiplied by minus 3, which is minus 3x. Inner, I've got plus 1 multiplied by x, which is plus x. And then the last terms we need to be careful. We have 1 positive, 1 negative. 1 times by 3 is 3, so this is going to be minus 3. We collect like terms. Minus 3x plus x is going to give us now minus 2x. So x squared minus 2x minus 3. And that now is fully simplified. We've expanded and simplified. So if you see a question that says expand and simplify and you're given a set of double brackets, just multiply them out. We'll do one more. Let's do a really hard one. 2x plus, in fact we'll have a minus. Let's have a minus in there. We'll do 2x minus 3. So 2x minus 3. Just popping this on. 2x minus 3. And then we're going to have now, let's go for x minus, let's go for x minus 4. Okay, so let's go ahead and look at this. So 2x multiplied by x is 2x squared. 2x multiplied by minus 4 is minus 8x. Minus x minus 3 multiplied by x is minus 3x. Minus 3 multiplied by minus 4, well 3 times by 4 is 12. We got 2 negatives, so it becomes positive. We have plus 12. So if I now tidy this up, we can go ahead and simplify. These are the like terms, so we're going to have 2x squared minus 8x minus 3x is minus 11x plus 12. So that now gives us our expanded term. Okay, so that now is using a double bracket to expand. Let's move on and look at inequalities. Now, inequalities are often confusing, but should generally make sense once you can get your head around them. Let's look at some basic notation. If I have now x is greater than 7, this means that the number we're looking for is bigger than 7. We can't include it as this is what we call a strict inequality. So if we were asked to find 3 integer values, 3 whole number values that satisfy this, we could have 8, we could have 100, and we could have 251. So this number, now if you want to just look at it, put a number in the box. Give me a number that's bigger than 7. Well, let's just put in here 10. That works. So x is greater than 7. Let's do another one. X is equal to or greater than minus 4. So this time we've got an inclusive inequality. We're going to have now a number that's at least minus 4. So I could include minus 4 as we've got now the inclusive inequality. I could have minus 1 and I could have 1. This number, the number in the box, must be at least minus 4. So if I put 5 in there, that works. Okay, let's have a look at another one. X, this number we're looking for, is less than 3. This is a strict inequality. So what we're looking for now are 3 integer values, 3 whole numbers that satisfy this. So I can choose anything. I can't have 3, but I could have 2, I could have 1, and I could have minus 10. All of those numbers, so if we put them in here, all of them 3 is greater than. It's saying I am bigger than you. I don't like to go back to the sort of primary school notation and terminology, but it's saying that 3 is bigger than this number. So let's put in a number. That works. That works too. So I'm just listing possible integers. Okay, let's have a look at another one. X is going to be equal to or less than minus 7. So this time we can include minus 7. This is inclusive. So this is a strict inequality. We can't include 7. This is strict. We can't include 3. This is inclusive. We can include minus 4 and we can include minus 7. So this number that we're looking for, some number in the box, has to be now at most minus 7. So minus 7 is going to be bigger. We could have minus 7. We could have minus 8. We could have minus 100. So these now are just simply 3 integers. So let's look. Minus 9 would also satisfy that inequality. So these are single, simple inequalities. Let's look at something slightly more challenging. Let's say we've got now that x is going to be now greater than 1, yet in turn less than or equal to 6. We might be asked to write down all of the integers that satisfy this inequality. So let's see what this is saying. What we want to do is find all of the numbers that this is true for. So just think, let's put some numbers in the box. Now quite clearly you're going to have to do this in order. Well, I'd say it's better to do it in order. Can we include 1? The answer is no. Can we include 2? Yes, we can. Can we include 3? Yes, we can. 4 we can. 5 we can. And 6 we can, as it's included. So all of these numbers would work. If you think 2 is bigger than 1, but 6 is bigger than 2. 3 is bigger than 1, but 6 is bigger than 3. And then we put here 6 is equal to 6, but 6 is bigger than 1. So these now are all of the integers that satisfy this inequality. So if we had now minus 7, and then we had x, and we had now minus 3, all of the integers that satisfy this are minus 7, minus 6, minus 5, and minus 4. We can't include minus 3 as this is a strict inequality. Okay, now sometimes, often on exams, you might be asked to graph these, okay? And what we're going to look at is just graphing them. And I'll draw a few on the same thing. Now, if this is going to be a strict inequality, we use an open dot. So when it's strict, we have an open dot. When it's inclusive, we have now a closed dot, and we colour that in. So if you want to make some notes, then when we have the inclusive inequality, we have now a closed dot. So what I'm going to do is now put some inequalities on. So what I'm going to have then is x is going to be greater than 2. So all I do, here's the number line, I locate 2, and I'll put 2 just here. We put now the open dot here, let's go ahead, put 2, and then it's going to be all values to the right. It's pointed in this direction, we're going to go right, and I'm just going to put my arrow on. Just think about this reasonably. Now, we can't include 2, but we could, for example, include 4. 4 is in here. So this is now representing this inequality on a number line. Okay, let's do another one. Let's say that we've got now at x is equal to or less than minus 1. We locate minus 1 on the number line. I know that I need now a solid dot, as this is inclusive. I'm going to put a solid dot just there, and then colour that in, and then we're going to take all values to the left. We want now, the number we're looking for has to be at most minus 1, so let's just colour that in. There we go, and we can go ahead and do that. So now it's going to be all of these numbers in this direction. So we can have minus 2, we can have minus 1 because it's included, minus 10, minus 30, and so on and so forth. That now is representing this on a number line. Okay, let's do this one. Let's say that x is going to be greater than minus 2, yet in turn equal to or less than 3. We locate minus 2 and we locate 3. So I'm going to put this on. This is going to be now minus 2, and we're going to have now positive 3. I appreciate that this isn't very accurate, but in the exam you will be given now a grid or some form of graph to draw this on. I can include 3, I can't include minus 2. All I'm going to do is put these on. So what we'll have is something that looks like this. So we'll have our open dot at minus 2, we will have our closed dot at positive 3, and I simply need to now draw a line between the two. So if we were asked now to draw that, we could. If we were asked to give integer values, remember integer just means whole number, integer values that satisfy this, we could say that that would be minus 1, we would have 0, and you can argue whether it's not an integer or not. That's not really up for huge discussion right now. 1, 2, and 3. They are all of the values that satisfy this inequality, and we can see that on the number line. There's minus 1, there's 0, 1 is just there, 2 is just there, and 3 is just here. So that is graphing them. So they're inequalities. We might be asked to solve an inequality. Generally speaking, we use the same technique as an equation. When you move on, if you do move on to any higher maths, we just have to be careful when dividing or multiplying an inequality by a negative number. In this section, I'm simply going to focus on positive numbers. So let's now solve the inequality 2x is greater than 4. Now, we solved 2x was equal to 4 earlier. All we did is divided both sides of the equation by 2. That's what I'm going to do with the inequality. We're going to divide both sides of the inequality by 2, so x is going to be greater than 2. That is your final answer. X doesn't equal anything. Don't write in that x is equal to anything. Now, if you are, and as much as I dislike saying this, if you are really not enjoying these symbols, you can solve the equation and then switch back. I prefer if you didn't, but it is an option for you. So let's have a look at this one. 3x minus 1 is equal to or less than 8. I'm going to add 1 to both sides of the inequality. So I'm doing exactly the same as I would with an equation. So 3x will be equal to or less than 9. Dividing both sides of the inequality by 3, so just putting this on, we're going to have now that x will be equal to or less than 3. And that now is my final answer. If you were asked for 3 integer values that satisfy this, we could have 3, 2, and minus 10. So that now is, if the question went on, you're treating these in a very similar manner to equations. The only difference is, if we had minus 3x is equal to or less than 9, if we divide both sides of this equation by, the inequality by minus 3, we need to change the sign around. I'm just going to include this example for completeness, but if we're dividing or multiplying the inequality by a negative number, we need to change the sign around. So we can say that x would be equal to or greater than minus 3. X doesn't equal anything. Don't write now that x is equal to minus 3. That's not right. This is an inequality. Now, you might say, well, why did that happen? If we just sort of look at this bit here, if I subtract 9 from both sides of the inequality and I add 3x to both sides of the inequality, we're left with this scenario. So we can see now that minus 9 over 3 would be equal to or less than x. So by swapping the sides at this stage, you can hopefully see now that this does hold true. Okay, so inequalities. Let's just finish with one more. Let's say 2x plus 7 is equal to, do another inequality rather than an equation, is going to be, let's say, and we'll go for less than, let's go less than 3x, and then we'll say minus 10. So what I'm going to do at this stage is now subtract 2x from both sides of the inequality. So just writing this out for my own notes, So minus 2x from both sides. I've got 3x over here and 2x over here. So 7 is going to be less than 1x minus 10. I'm now going to add 10 to both sides of the inequality. So plus 10, and we're going to end up with 17 is less than x, or x is greater than 17. Again, if you want integer values that satisfy that, 18, 19, 104. They are just 3 examples. So vary inequalities. Simplifying basic work with inequalities, solving inequalities, writing them and graphing them. Okay, so that now is inequalities done. Let's move on to sequences. Now, when we're looking at sequences, the first thing to do is look out for obvious sequences. So if I now started with this particular sequence, 1, 4, 9, 16, 25, and we were asked to find the next 2 terms, we should be spotting this particular sequence of numbers. These are the square numbers. This is 1 times 1, 2 times by 2, 3 times by 3, and so on and so forth. Therefore, what we should do now, this is 5 squared, we'd have 6 squared, which is 36, 7 squared, which is 49, and we would write the rule is square numbers. So that is the rule. So square, I don't want to write rule, I just said rule, I want to write square numbers. So the rule is that this now is the sequence of square numbers. You will need to be able to state now, so square numbers. There we go. Let's look at another one. 1, 8, 27, then we're going to have 64, and we need to find the next 2 and state the rule. This time we have the cube numbers. This is 1 times 1 times 1. This is 2 times 2 times 2. 3 times by 3 times by 3. So that's 4 cubed. We're going to have 5 cubed, which is 125, and 6 cubed, which is 216. And we would say these are the cube numbers. So that now is certainly ones that we should be spotting. Let's look at some others. Let's say we've got a really, really basic sequence. 2, 4, 6, 8, 10. And we were asked to write down the next 2 and write a rule. We can see quite clearly it's going up by 2 each time. So what we're going to do is just simply write now that this would be 12, 14, and the rule is add 2 each time. So add 2 each time. Now, when I'm talking about a rule, add 2 each time. When I'm talking about a rule, I'm not talking about the nth term sequence. We're going to come on to nth term shortly, but this is just a rule for this sequence. Add 2 each time. Okay, let's look at another one. The next one we're going to look at, let's go for, let's say we've got 2, 3, 5, 8, 12, 17, and we're asked, let's 12 and 17, we're asked now to find the next 2 in the sequence and write a rule for the sequence. So let's do that. Let's go for 17, and then we'll go from there. Okay, now I can see that it's not going up by the same amount each time. Let's think about using a bit of logic. This has gone up by 1, this has gone up by 2, this has gone up by 3, by 4, by 5, so the next one should go up by 6. 17 plus 6 is 23. So that's gone up by 6. The next one should go up by 7, which will give me 30. And we're going to write that the rule is add 1 more, so add 1 more each time. So add 1 more each time. So with these, it's just a case now of seeing what is happening. Let's go for another one. 1, 2, 8, 64, 32, 16, 8, 4. Now what we want, and we'll do another one, and we want the next, let's do the next 3 terms. So what's happening here? Well, 128 to 64, 64 to 32, 32 to 16, it's halving each time. or we're dividing by 2. So if we look at this one here, if we divide 2 by 2, we're going to get 1. If we divide 1 by 2, we're going to get 1/2. If we divide 1/2 by 2, we're going to get 1/4. And we could say halving each time, or dividing by 2. So divide by 2 each time. So just look at your sequence. See if you can find a pattern and just work from there. Let's do another slightly more challenging one. Let's do 2, 3, 5, 7, 11, and we want the next 2. So let's see if we can spot this and see if anything's going on. Well, that's going up by 1, that's going up by 2, that's going up by 2, that's going up by 4. But what type of numbers are these? Well, 2 is a prime number, 3 is a prime number, 5 is. So what we're looking at are the prime numbers. So being able to spot these is quite important. So the next one is going to be 13 and then 17. And we would state now that these are the prime numbers. So prime numbers. Some of these questions will be in terms of gates and fences, and you've got to give a rule for the number of posts compared to the number of fences or slats. Just use some logic and state a rule. Adding 1 each time, adding 1 more each time, dividing by 2, multiplying by 2. You could have even, if we went the other way with this, the powers of 2. Okay, let's move on. We've looked at sequences, we've looked at inequalities, so let's now mark those off. So inequalities done, sequences are done. Let's go at and look at expanding, well, say expanding if you pardon the pun, moving on to now the nth term. Now, the way in which I'm going to teach this is quite ploddy. You could argue that it could be done slightly better. I actually like it this way. What we're going to do is have what we call an arithmetic sequence. An arithmetic sequence has a common difference or a fixed difference. So let's look at now 4, 7, 10, 13, and then we'll have the next one, which is going to be 16. So let's see what this is going up by each time. That's adding 3, that's adding 3, that's adding 3, and that's adding 3. So this is what we would call an arithmetic sequence. Sometimes that word will be used, sometimes it won't. It just means it has a fixed difference. So if one of these wasn't going up by 3, then we wouldn't use the nth term for this particular sequence. What I like to do here now is fill in a table. We're going to have n and we're going to have t. T is the term in the sequence, and we can see that this is going to be 4, 7, 10, 13 and 16. N is the number of the term. This is the first term, second term, third term, fourth term, fifth term. I can see that it's going up by 3 each time, as we've just seen. So it's plus 3. At this stage, I'm simply going to do 3n. I'm going to write 3n. It's going up by 3 each time. If I substituted n is 1 into here, 3 times 1 is 3, what would I do to get to 4 from 3? The answer is add 1. This is the nth term of this sequence. Does it work for this one? Well, 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. 3 times 4 is 12, plus 1 is 13. So this is a nice, straightforward example. If you said add 3 each time for the nth term, that is incorrect. That is a rule for the sequence. If we're asked to find the nth term of this, it's 3n plus 1. So let's look at a tough question that in an exam they might ask us. They might say is the number 40, let's go for 49 in this sequence. So what they might do is give you a number that's so far out. I mean, this isn't too bad, but you don't really want to be counting up. If this is in there, what we can say is that 3n plus 1 would be equal to 49. And what we want to do is get an integer or whole number value for n. So I've got an equation to solve. So I could say now that 3n, subtracting 1 from both sides is 48. Dividing both sides by 3, that would give us 16. 16 is a whole number, so yes, 49 is in the sequence as it's the 16th term. So that's your typical extension question on. If we were asked to find now the 24th term, so if you're asked to find the 24th term, let's just substitute n is equal to 24. So when n is equal to 24, 3n plus 1 becomes 3 lots of 24 plus 1. 3 lots of 24 is going to give me 72. 72 plus 1 is 73. So that's the 24th term. So finding a term and seeing if another number is in there. Let's look at another example. Let's go for a different sequence, and we will say now that we're going to have, let's go for, we will go for 5, we will go for 11, we will go for 17, we will go for 23, and we will go for 30. And we want to find the nth term. Now, I've purposely written 30 at the end because I want you to check. If we're not told that this is arithmetic, I want you to check that it is going up by a fixed amount. So that one is going up by 6, that one is going up by 6, that one is going up by 6, that is going up by 7. Therefore, this is not arithmetic. So if you're asked, do check. So we need to make this one at 29, so it is arithmetic. Okay, so setting up my little table, let's go ahead and do that. So set up my little table here. What we're going to have now is the term. The term in the sequence is the one that we're given, 5, 11, 17, 23, 29. The number 1, 2, 3, 4, and 5. So I know the common difference is plus 6. So I know it's going up by plus 6 each time, therefore I write 6n. If we consider now when n is equal to 1, we're going to have 6. 6 times 1 is 6. What do I need to do to get to 5? The answer is subtract 1. So our nth term is 6n minus 1. Does that work here? Well, 6 times 2 is 12, minus 1 is 11. 6 times by 3 is 18, minus 1 is 17. That works. That is the nth term. The nth term is not plus 6 each time. That is just a rule for the sequence. The nth term is 6n minus 1. Right, let's do something, again, slightly more challenging. Let's say we've got now 7. We have now the next one, which I'm going to make 3, minus 1, minus 5, minus 9. So what's happening here? Well, that's going down by 4. That's going down by 4. That's going down by 4. And that's going down by 4. So this time we're going to have minus 4n. You might want to abandon the table at this stage. I still use it, and I strongly advise using it. And this will just give us the values. So n is going to be, now let's put that in. So terms 7, 3, minus 1, minus 5, and minus 9. This is the first, the second, the third, the fourth, and the fifth. So what we're going to start off with is minus 4n. So that's what I'm starting with, as it's going down by 4. It's not plus 4n. So if I do minus 4 lots of 1, that gives me minus 4. What do I need to do to get 7? The answer is plus 11. So it's minus 4n plus 11, or you could write this as 11 minus 4n. I actually prefer it like this, but to keep consistency with what you've been doing before, we'll just stick with this. So if we think, if n is 2, minus 4 times by 2 is minus 8, plus 11 is going to give us 3. So we can see it works here. Minus 4 times by 3 is minus 12, plus 11 is minus 1. And you can see it keeps going. So that now is the nth term. So if we were asked now if the number 31 is in here, let's have a look if the number 30, in fact, let's go for something more reasonable, as we know 31 can't be. Let's go for minus 31. Is minus 31 in now this sequence? So what we'd say is minus 4n plus 11 is equal now to minus 31, and we have the equation solved. I'm going to add 4n to both sides of this equation, so plus 4n, and we're going to have 11 is equal to 4n minus 31. I'm going to add 31 to both sides of the equation. Remember, I'm just isolating x, so that's going to give me 42 is equal to 4n. I'm now going to divide both sides of the equation by 4. 42 over 4 is not a whole number. So just writing this in, 42 over 4 is equal to n. We could simplify this to 21 over 2. 21 over 2 is 10.5. So we can say it isn't because n is not an integer. If this worked out to be 10 or 11, yes, it would be a man. But the fact that it doesn't gives us that. If we wanted to find, let's go back to this right here. If we wanted to find the 50th term, then n would be equal to 50. So we'd have minus 4 lots of 50 plus 11. So minus 200. Remember, 4 lots of is just multiplying. Plus 11, which is going to give us minus 189. So that's a 50th term. So that is the nth term of a sequence. Look out for wordy questions that involve that. If they do, that's about as challenging as it can get. Right, let's go on and look. Let's tick this one off. Let's look at formulae. So, formulae, now there are two particular real areas I want to focus on. Okay, one of them now is to simply, and we can look at this two different ways. A formulae might be the cost is equal to 2m plus 1. So this is an example of a formula. So this might be the cost, and this is the number of miles. So we'd have 2, however many miles we travelled, plus 1. Okay, so let's look at an example. Let's see now, substituting in when m is equal to 3. So what we might want to do is find the value of c. So c would be equal to 2 lots of 3 plus 1. C would be equal to 6 plus 1. So c would be equal to 7. So this is a formula, and this is just substituting a number in. Okay, now what I'm going to do is just define this later. Well, we'll do it later. We'll do a couple more of these. Let's say now another one. Let's say that p is equal to 3x minus 4y, and we have x is equal to 1 and y is equal to, let's go for 5. So what we could say, substituting in 3 lots of 1 minus 4 lots of 5. So p is going to be 3 minus 20, so p would be equal to minus 70. So that now is just substituting in. Just have numbers, nice and straightforward. Be careful with your positives and negatives. So if we change now, let's say we changed these over, and we said now that x was in fact equal to minus 2, and that y was equal to minus, let's go for minus 3. So what I'm going to do this time is just substitute these in. So p is going to be equal to 3 lots of minus 2 minus 4 lots of minus 3. So we have now a positive and a negative number, that's minus 6, and 2 negatives, which is going to give me a positive, that becomes plus 12. So p is going to be equal to minus 6 plus 12, or 12 minus 6. P in this case would be 6. So this is simply substituting into a formula. Be careful with some of them. Let's just do a couple more. Let's say now that we're asked to find, let's say we're asked to find now the value of, and let's say x squared minus 3y, and we can say now to begin with, when x is equal to 2 and y is equal to 5. Okay, so let's look at this. What we've got then is 2 squared minus 3 lots of 5. This is going to give me now 4 minus 15, and that's going to give me now minus 11. So minus 11 would be now my final answer. So all I'm doing is subbing it in. Let's say we had now when x instead of x is equal to, when x is equal to minus 3 and y was equal to minus 4. So this time we'd have minus 3 squared minus now 3 lots of minus 4. So all I'm doing is taking it and subbing it back in here. Now, minus 3 squared, if we square a negative number, we get a positive number. That's saying minus 3 times by minus 3. Minus 3 times by minus 3 is going to give us positive 9. Then we'd have now plus 12. So that's going to give me now 21. So all we've done is sub that in. Right, let's go back to this right here, this formula. Okay, so what we got is C is equal to 2m plus 1. Now what this is a taxi journey. Let's say this is a taxi journey. And let's define what C and M are. C is equal to the cost. M is equal now to the number of miles. So M is a number of miles. So number of miles. So what we might want to do is find, let's say, find the cost. So find the cost when the miles when, let's say, when 6 miles are travelled. So 6 miles are travelled. Let's find the cost. Well, the cost is going to be now £2 a mile. This is simply saying that it costs £2 a mile, and this is what we call our constant. So what we're going to have then is £2, 2 lots of the 6 plus the 1. So the cost is going to be 12 plus 1. The cost would be 13. And let's just make this a little easier to see. We'll do another one because I don't think I've defined this too clearly. Cost in pounds, and this is a number of miles. This is £2. It's saying every mile we travel will be charged £2, and then we get charged £1 for getting in. So this would give us an example. Now we might be asked to find how many miles. So find how many miles were travelled, and were travelled. Just hit pause if you are struggling to kind of keep up with what I'm writing, because I'm scribbling. How many miles were travelled now if the charge was £21? So how many miles were travelled when the cost was £21? So all I'm going to do now, I know that C is equal to 2m plus 1. The cost this time is 21, and that's equal to 2m plus 1. We're finding the number of miles, which is m. Subtracting 1 from both sides of the equation, 2m is equal to 20. Dividing both sides of the equation by 2, m is 10. So we could say 10 miles were travelled. Let's do another formula. Let's say now the price of a mobile phone tariff is going to be now, and we'll say it's £2 a minute. So £2 a minute, so 2m, and then we're going to have a fixed £10 monthly line rental. So this is the price. So I've written this. This is the price, now the total price. So let's write this in. Total price in pounds. This is going to be now the cost per minute. So this is the cost per minute in pounds. Cost per minute in pounds. This is going to be now the fixed monthly charge in pounds. So fixed monthly in pounds. Okay, so fixed monthly in pounds. Right, so let's work with this. This is a formula. So what we might want to do is find the total price if I use 30 minutes. So what we want to do is find the price if 30 minutes have been used in that month. So let's go ahead and just sub that in. So the price would be now £2. We'd have 30 minutes plus 10. So it's saying that I'm going to be charged £2 per minute. I've done 30 minutes. So it's 2 times by 30. So the price is 60 plus 10. So the price is going to be 70. And I just write my answer now as £70 using the correct units. Okay, let's now work out how many minutes if the cost, and let's say price, we'll make the price equal to, let's make it £150. Let's say I got this bill of £150. How many minutes were used? So that's my bill. How many minutes? So how many minutes did I use? Okay, so let's set this up. This time we've got the monthly price. So 150 will be equal to 2m plus 10. We want to know the number of minutes I've used. We subtract 10 from both sides. 140 is equal to 2m. We divide both sides of the equation by 2, and we can see now that that's 70. So we can say now that 70 minutes were used. So 70 minutes used. Okay, now in some questions we're going to look at graphing these, and we'll come on to graphing. I just really want to get the basics down for this. If we just quickly look at this though, I think it's important to stress now, at this stage they might ask you what is the fixed cost, or what would you have to pay if you didn't make a call at all. Now this £10 is the monthly line rental. So if you didn't make any minutes, M would be naught, and the price, so for example, if you took your mobile phone contract out and you lost the phone the second you bought it, you'd still be paying £10 a month. So this fixed price is what we have. I'm just going to draw a quick graph of the two, and of just these two particular ones here. In fact, I'll just do two. I'll do two different ones. So let's just look at this right here. What I'm going to do is have two mobile phones. So mobile phone 1 is going to be now £1 per minute. So I can just write M, and then it's going to be plus 20. We would have mobile phone 2, which is going to be this one just here. This is going to be 2M plus 10. So on this one here, we know we're being charged £2 a minute and £10 line rental. This one, we're going to be charged £20, but only £1 a minute. When we come on to graphing shortly, we will look at this in more depth. All I'm going to do is draw these. So what I'm going to have on the first one is something that looks like this, okay? So what we have then is the cost. This is the monthly price. So what we have here is M. That's the monthly price. In fact, let's put it as price. And let's put this as now the minutes, okay? So what we have then is if we use no minutes, we have £20. But on this now, this has a gradient of 1. So if we use 1 minute, it'd be 21. So we could put this point just here. This would be 121. We would have 222, and so on and so forth. Now if I drew this one, and I'm just going to put that this is mobile 1. If we put the next one on, our initial cost is lower, but our bill will be higher if we now, or I should say the number of, the cost per minute is higher. Now I don't know how accurate this is, but what we'd have is 0, 10. So this point now, if I use 1 minute, it would be £12, okay? So let's just put this in, because it's £1 a minute. There's going to be some point here where they cost the same for a certain number of minutes. As I said, this isn't accurate, but it will give you some idea. So this is M2. So for calls up to this minute, let's say this was, and we, of course, we could go ahead and work this out to find out what it's going to be, which is actually going to be 10 minutes. After, and we could, of course, if we wanted, and I'll just take this on a bit, M plus 20 will be equal to 2M plus 10. Subtracting M from both sides, we'd have 20 is equal to M plus 10. Subtracting 10 from both sides, M would be 10. So at this point, these are the same. Again, I've solved an equation. You wouldn't generally be expected to do that unless it's a really tough question. So what we can say at this point, and apologies if this isn't massively accurate, we could say up to 10 minutes, mobile phone 1 was the best tariff. After 10 minutes, the mobile 2 is, because we can see now that this is going to be more costly at this point onwards. So that's having a quick look. We will be looking at graphing lines shortly, but hopefully that gives you some idea. So if you're given a graph, this point right here, you can say to yourself, well, after that point, it's going to be more expensive. Okay, so that's looking at formulae. What we're now going to do is look at rearranging formulae. So what we might have then is a formula or an equation. V is equal to U plus AT. This is from physics. If you've done any physics, you might recognise this. At the moment, V is the subject of the equation. We might want to make U the subject of the equation. When we're talking about the subject of the equation, we're saying that V is equal to something. So we've only got V on one side. So if I want to make u the subject of the equation, I just want u. We do this in the same way we solve equations. So all I'm going to do to make u the subject, and generally we would just write u as our subject, we would subtract at from both sides of the equation. So v minus at is equal to u. U has become the subject of that equation. So it's now u expressed in terms of the other variables. Okay, so that's making u the subject. What about making a the subject? So what I want to do is undo this. Now if we go back to an equation, 2x minus 1 is equal to 5. To solve for x, we would add 1 to both sides, so it would become 2x is equal to 6, and we'd divide both sides of the equation by 2, and x would become 3. So starting back here, making a the subject of this equation, the first thing I'm going to do is minus u from both sides of the equation. So let's set this up step by step. V is equal to u plus at, and we're making a the subject. So I'm going to minus u from both sides of the equation. So minus u. That would give me v minus u is equal to a multiplied by t. I just want a, so we're going to have to divide by t. Just imagine t as a number. Say t is 5. So if I divide both sides of the equation by t, it's v minus u divided by t is equal to a. And we've made a the subject of the equation. We're undoing it using the order of operations. So let's say we had p minus 3 divided by q is equal to r, and we wanted to make p the subject of this equation. The first thing I'm going to do is multiply both sides of the equation, or the formula, by q. I can see that p minus 3 divided by q is equal to r, so we can say that p minus 3 is equal to q times by r. I want p by itself, so I'm going to add 3 to both sides of the equation, and that is going to give us that p is equal to q multiplied by r plus 3. Now p is the subject of the equation. It says p alone is equal to something else. So that now is rearranging a formula to make something the subject of that formula. So all you're doing, exactly the same as the equation, you go ahead and solve it. Okay, let's move on to straight line graphs. Plotting straight line graphs. What I've got here is now an axis. Let's just get nice and comfortable with some basics. This is the x-axis. This is the y-axis. To begin with, I'm just going to draw some straight lines. I'm going to draw now a horizontal line. This is the line y is equal to 2. So on here I could write y is equal to 2. This is a horizontal line. The y lines are horizontal lines. So if I had now this line just here, y would be equal to minus 2. If I put the line just here, y is equal to minus 3, y is equal to minus 4, and y is equal to minus 5. So if you're asked to graph those lines, those are ones that you should remember from lower down the score. So y is equal to minus 5. Let's now look at some vertical lines, and we might have this line right now. This is going to be x is equal to 1. So that line is x is equal to 1. In fact, let's just change that over. Let's put a solid line. X is equal to 1. This is x is equal to 4. Okay, x is equal to 4, and we can label those up. This is going to be x is equal to minus 5. So let's just start with those basics. So this one right here, x is equal to minus 5, x is equal to 1, x is equal to 4. In this section, we're going to look at graphing straight lines. I'm going to look at a few different examples, and then we're going to go ahead and plot these. First one I'm going to start with now is y is equal to 3x minus 1. So I've given an example in the box if you want to read it. and we're going to do this now, and often it will say for x between now -2 and +2, or -2 and +3. I'm going to start off now with -2 and +2. So we've met this inequality before, and we're going to go ahead and do this. So what I'm going to do is simply label this up now, x and y. So x and y. So we're going to have -2, -1, 0, 1, and 2. So all I'm going to do, and I'll do this one very step by step to begin with, we're going to start now. I actually like to start here. If I'm going to be 100% honest, I like to start at 0. 3 lots of 0 minus 1 is going to give me -1. 3 lots of 0 is 0 minus 1. So now I'm going to have -1 in here. If we take x to be 1, y is going to be 3 lots of 1 minus 1. That's going to give me 2. At this stage, you might have spotted that it's going up by this fixed amount of 3. If not, we can go ahead and do the next one. When x is 2, 3 lots of 2 minus 1, that gives me 5. Okay, so all I've done is subbed in values of x. We can see that this is going up by 3. Therefore, if you don't want to work the others out, you can simply go down by 3. So we're going to have now we're going to have on this one -2. So when we've got in the -1, and then we're going to have on the next one, if we sub this in, sorry, it's going to be -3. So it's going down by 3. So it goes down by 3. Let's put that in and let's correct that. So -3, and then this one is going to go down by another. Now, what are we going to have on here? So let's just check. That's going down by 3. We're going to go down by 3. We're going down by 3 each time. In fact, this is a poor explanation. Let's just get shot at that. So we're going down by 3 each time. I will get it right. That's going to be -4 and then -7. As you can see, after over an hour and a half, I'm starting to not be able to subtract numbers. So we could do that. You could, of course, work them out if you really wanted to. So I've worked them out here for the positive and the negative. So if we did now 3 lots of -1, -1, this would give us y is equal to -3 minus 1, y is equal to -4. I was kind of trying to show a quicker way of doing it, but then couldn't add my numbers. Right, so we'll be asked to plot this. Hopefully the next one will make a bit more sense. So on the grid, if you're given a grid, make sure that the x and the y coordinates are labelled up the same. So sometimes they take 2 jumps. So for example here, they might go up in 2s and this one might go up in 1s. Always check. So what we're going to have in, this is the origin. We've got 1, 2, 3, 4, 5, and so on. We've got -1, -2, -3, -4. We've got 1, 2, 3, 4, 5, 6, and then we've got these. These will generally be labelled. So -3, -4, -5, -6, and so on and so forth. Now all we need to do is plot at least 2 points. Your graph should be a straight line. So let's start here. I always like to start nice and straightforward. I'm going to see now that I've got an x coordinate of 0, y coordinate of -1. 0 minus 1 is here. This one here, I've got an x coordinate of 1 and a y coordinate of 2. So I'm going to have now 1, 2. We can see this has a gradient of 3. It's going up by 3 each time. This one is 2, 5. So if we do 2, 5, 2, 5 is going to be there. You can plot these points if you want, but if we draw a straight line through these points, it should now go ahead and hold. We're asked to draw this from -2 to +2. So -2 is going to give me just there, and we can see that it goes through. So that is all we're asked to do. That is what we've done, and we can label this up. Y is equal to 3x minus 1. So y is equal to 3x minus 1. So that one is just there. Remember, this is -2 minus 7. Then we've got now -1 minus 4, and we can see that they lie on there. So all I've done is filled out a table of values. So let's have a go at another one, and we'll do this one. So what we're going to have then is the following. We're going to have y is equal to, let's go for, we'll go for 2x plus 1. So what I want to do is draw this graph now. As we can see from here, this is exactly what we've got. And this time we're going to take x from -3 to 3. Okay, so drawing up the little table of values, you don't have to, but showing some working is going to be important. What we're going to have is x and the corresponding y coordinates. So if we have x and we have y, we're going to take it from -3, -2, -1, 0, 1, 2, and 3. Okay, so now if we want to, we'll just literally fill this in. 2 lots of 0, and I'm going to start here. 2 lots of 0 plus 1 is going to give me 1. 2 lots of 1 is 2 plus 1 is going to give me 3. We can see it's going up again by this 2. 2 lots of 2, that's going to be 5. That's going to be 7. Therefore, and hopefully I'll get this right this time, -1, -3, and -5. So if I'm going up now by 2, I need to be going down by 2. And if you think about this now, if we'd done this one, y is equal to 2x plus 1. When x is equal to -3, y is 2 lots of -3 plus 1. Y is equal to -6 plus 1. Y is equal to -5. So you can still do it. Okay, so let's go ahead and plot these. Now I'm not going to label this up. All we're going to do is locate now these coordinates. So let's start now with 0, 1. So 0, 1. So 0, 1, x is 0, y is 1, just there. 1, 3, well there's 1, there's 3. Then we're going to have now 2, 5, that's 2, 5, which is just there. Then we're going to have 3, 7, which is just there. So all I've done is plotted these. Again, if you want to put them on, if you're still learning, that's perfectly fine. You can put these on. So what we're going to have then is 1, 2, 3, 4, 5, and so on. We only need to go up to, and then we're going to have -1, -2, -3. Now at this stage we can go ahead and put -1, -1. -1, -1 is going to be there. Then we're going to have -2, -3, which is going to be just here. We're going to have -3, -5. So all we need to do is draw a straight line and check that we've done this for the values that they want, and we can do that. We can put that on. Let's go ahead and put that on, and that now is the line y is equal to 2x plus 1. Okay, let's have a go at another one. Let's do something slightly different. Let's do now y plus x is equal to 5. Now what you could do is rearrange this as y is equal to 5 minus x. Alternatively, we can just use a bit of logic. What we're going to do now is x from, and we'll go from -3 again to +3. So if we look at this now, setting this up in a table. The way I like to do this is slightly different, but again, you can revert back to writing this now if you wanted as y is equal to 5 minus x. If you see it that way round, that's perfectly fine. So what we're going to have is x and y's. So we're taking x from -3, so we'll have -3, -2, then we'll have -1, we'll have 0, we'll have 1, we'll have 2, and we'll have 3. So the way I like to think about this now is the following. Starting with x is 0, if x was 0, what would we have to do with y? Well, y would have to be 5. If x was 1, we'd have to make y 4. If x was 2, y would have to be 3. 3 plus 2 is 5, so this would become 3. If x was 3, y would have to be 2. We can see now that this is going down by 1. So if x was -1, this would be 6, this would have to be 7, and this would have to be 8. So it's entirely up to you. All I've said to myself now, if x is going to be 0, y must be 5. If x is 1, 4 plus 1 is 5. If x is 2, y's got to be 3. And we've got these points. Alternatively, you could have just done it this way. So if you'd rearranged it to y is equal to 5 minus x, well 5 minus 0 is 5. 5 minus 1 is 4. 5 minus 2 is 3, and so on and so forth. My only concern is with the negative numbers, as I appreciate some students do, and I can understand why, get a bit baffled every now and then. So all we're doing is going ahead and plotting this. So again, we're interested now in 1, 2, and 3. -1, -2, and -3. I might go off the grid here, but this will give us some idea. We're going to have now 1, 2, 3, 4, 5, 6, and 7. And then we're going to have now -1, -2, -3, -4, -5, -6, -7. And I'll put -8 down here. So if we look now, 0, 5. So let's put that on, and I'll choose a different colour this time. We'll have this one. So we're going to have 0, 5. So 0, 5, x is 0, y is 5. X is 1, y is 4. And we've got now on here, let's go ahead. We needed that 8 up here, didn't we? So 1, 4. We've got 2, 3. Let's find 2, 3. 2, 3 is just there. Then we're going to have 3, 2. And then quite clearly we're going to go the other way. So we're going to have this one, we'll have that one, and we'll have that one. So what I need to do now is simply draw a line through that, and we can say that that is that particular line. Now, y plus x is equal to 5 for those values. So entirely up to you on how you want to deal with that. Okay, let's just move on and look at just a bit of an extension from this. So that was a straight line graph. We're going to look at our quadratic graph. A quadratic graph, let's have y, we'll have y is equal to x squared plus 2x minus, let's say we've got minus 1. Now, I'm just going to graph this out roughly, and we'll do a table of values first. So what we might have is x is going to be between, let's go from minus 2 to positive 2. Now, this time we're going to have a curve. This is a quadratic graph. A quadratic equation has a term in x squared. So when we see an x squared, this means that it's what we call a parabola, okay? And we're going to deal with this now. So let's go ahead and draw a table of values. So table of values, and we're going to look at now the following. So what we need to be careful with is when we're squaring negative numbers. So x, and then we're going to have y. We'll have minus 2, we'll have minus 1, we'll have 0, we'll have 1, and we'll have 2. Okay, now I'm going to start. We can't just subtract on this one. We're just going to have to go from here. So let's start with x is equal to minus 2. So y is going to be equal to minus 2 squared plus 2 lots of minus 2 minus 1. Okay, so if we think about this, when we square a negative number, it becomes positive. So y is going to be equal to 4. We've got a negative and a positive. That would be minus 4 minus 1. 4 minus 4 is 0. Minus 1 is going to give us minus 1. So when x is equal to minus 2, y is equal to minus 1. So we can put in minus 1. Let's now look when x is equal to minus 1. Y will be equal to, we're just subbing this into this equation right here, minus 1 squared plus 2 lots of minus 1 minus 1. So y would be equal to minus 1 squared is 1, minus 2 minus 1, then y is going to be equal to minus 2. So if we now take x to be equal to 0, y will be equal to 0 squared, which is just 0, plus 2 lots of 0 minus 1, and y will be equal to minus 1. If we take now x is equal to 1, y will be equal to 1 squared plus 2 lots of 1 minus 1. So y will be equal to 1 plus 2 minus 1. So y will be equal to 2. When x is equal to 2, y will be equal to 2 squared plus 2 lots of 2, and then we're going to have minus 1. So y is going to be 2 squared, which is 4, plus 2 lots of 2, which is 4, minus 1. Y would be equal to 7. What we should have now are these points, and these are going to form a parabola. So minus 2, minus 1, 2, and 7. So let's go ahead and plot these on the graph. I'm hoping that you can read these rather than me labelling them up each time, but let's go ahead and do this. So what I'm going to do is start with 0 minus 1. So 0 minus 1 is where x is 0, y is minus 1. We're going to have 1, x is 1, y is 2. That's just there. We're going to have now 2, 7. 2 is just here, and then 7 was just there. This now, we can go the other side, minus 1. Then we're going to have now minus 2, which is going to be just here. So minus 1, minus 2. Then we're going to have minus 2, minus 1. This gives us a sweeping curve, or what we call a parabola. You do not connect this now with loads of jerky lines. It's a flowing curve. The flowing curve does something like this. It comes round, it comes up, and we will do now a curve. The curve on here isn't going to be brilliant because that's my drawing. But the curve, essentially, if we completed it, would look something like that. It looks like a bucket. The world's most famous parabola, or parabolas, are the McDonald's signs upside down. So when you see those McDonald's signs, they are upside down parabolas. So it should be a nice sweeping curve, not jerky lines. I mean, mine isn't brilliant because on the tablet it's quite hard to do. So that is drawing a quadratic graph, and this graph is y is equal to x squared plus 2x minus 1. If you were asked to find out where it was equal to 0, this is where it's equal to 0, y is equal to 0 just here. So that's a kind of question they might ask. Okay, so that's a quadratic graph. What we're going to do is just finish up with looking at a couple of different things. What we're going to look at is the midpoint of a line. So we're going back to straight lines, and we're going to look at the midpoint of a line. This appears in the help sheet. It's just cut off at the bottom. I've got it a few on, but as we've got the axis. Okay, what we do is add the x's together, so x1 plus x2, and divide by 2. We add the y's together and divide by 2. So what we're going to do, and this looks really, it looks really bewildering. What I'm going to do is plot now a point, and hopefully this will make sense. So we're looking at the midpoint of a line. So let's start with something really nice and straightforward. This is going to be the point 1, 1, and then we'll take the point now 5, 3. Okay? So what I want to do is find the middle of this line. Now I could do this purely by drawing a straight line across here, and then realising that we can see that the middle of that line is bang on an integer value. And that integer value just here is going to be 3, 2. So how did that work based on this? Because it's not always going to be this pretty. So what I've done is added the x's together, 1 plus 5, and divided by 2. And I've added the y's together, 1 plus 3, and divided by 2. This gives me 6. 6 over 2 is 3. And this gives me 4. 4 over 2 is 2. So that's the midpoint of a line. Often it's not going to be that nice. So for example now, if we had a line that didn't pass, and let's do something like this. Let's say we had something that looked like that, okay? And we'll do, let's make something a bit, there we go. So what we're going to do is find the midpoint of this line. Generally you'll be given the coordinates. So if we look at this now, this point here is going to be 1, 3. This point is going to be, what have we got, 5, so that's going to be on here, let's just check that, that's going to be 5, 6, isn't it? Okay, now we can see the midpoint somewhere here, but all we need to do to find the midpoint, and I'm going to call this m is going to be 1 plus 5 divided by 2. Then we're going to have now the y coordinates 3 plus 6 divided by 2. So that's 6 over 2, which is 3, and this is 9 over 2, which is 4.5. Now if we look at that, we can see that that is the case, okay? But we can't just guess, we need to show some logic, and that's that point just here. Now it's halfway between the two numbers. So what's, oh, you could look at it this way. What's halfway between 1 and 5? Well, halfway between 1 and 5 is going to give me 3. Halfway between 3 and 6 is going to give me 4.5 or 9 over 2. So the midpoint of a line is simply now saying to yourself, what points have I got? And you're finding halfway in between, or you're just using this particular formula. Okay, let's start with a really nasty, or finish on this one with a really nasty one. Let's say now we had the following. Let's say we were told now that we had a line AB, and this is a bit of a nasty example, and we said now that the coordinates of A were going to be 3, 1, and we'll take the coordinates now of the midpoint. So if we say now the midpoint, so we've been given A, let's say the midpoint now, let's take the midpoint to be 1, let's say 1, 2, and what we want to do is find B. So this time we've been given the midpoint. Now if we had a bit of graph paper, we could see this in action. The way I like to think about this now is this is the midpoint. Now just sketch a line. Let's avoid using, this doesn't have to be accurate at all. So what we've got then is this one right here. This is A. We've got 3, 1. We've got now B somewhere down here, and we need to find the coordinates of this. And we've got the midpoint here. The midpoint is going to be 1, 2. I like to say to myself, what did I do to get from 3 to 1? The answer is I subtracted 2. So I'm going to subtract another 2. Because if I add 2, I get here. If I add 2, I get here. What did I do here? Well, I added 2, so I need to go ahead at this stage and add now. So I've added 1 at this stage. I need to add another 1, which is going to give me 3. So we can say now, from 1 to 2 is 1. We add another 1, and that gives us now the point 3. Now, of course, you could have sketched this up. So if we do this, let's find 3, 1. Let's choose a different colour on here. So what we've been given now, 3, 1. So this is 3, 1. That was A. We were told the midpoint now on here was 1, 2. So let's go ahead and locate 1, 2. 1, 2 is going to be just there. And what we wanted to do is find the point B. Now, if you put a straight line through this, let's go ahead and do that. It's going to look something like this. So let's just put there, and we want B. Now we can see by putting that straight line on that that is in fact what we're going to get. We're going to get -1, 3, and that's B. And we can see that's the midpoint there. So if you think about it recently, what did we do? Again, this isn't very accurate at all, but it just gives us some idea of what we're doing. Okay, so there we go. That now is finding the midpoint of a line. I think to finish off with the last couple of minutes, we're just going to look at a couple of different problems that you might come across. The main section of problems that you're going to look at will be on the other part of the series here. But let's just finish with some equations. So what we're going to have then is an equation solve. 2x squared is equal to 72. So what I want to do now is solve for x. I'm going to divide both sides of the equation by 2. So we're going to have x squared is equal to 36. I want to now find the value or values of x. Before, we've looked at this and we know that the inverse operation, so the inverse was to divide by 2 and divide by 2. I'm now going to square root both sides of the equation. Now, the square and the square root are the inverse, the same as multiplication is to division and now subtraction is to addition. So x is going to be equal to, and as we stated, it was technically plus or minus the square root of 36. So x would be equal to plus or minus 6. On a foundation paper, generally you would probably get away with just putting 6, but I think it's important to stress that that's the case, that there's a plus or minus answer. And that's what we'd have. So there we go. That's a nice example. A nice example of an equation like that. So for example, if we had, let's say we had x squared minus 1 is equal to 24. To solve this equation, we would add 1 to both sides of the equation. So that would give me x squared is equal to 25. We need to square root both sides of the equation. So if I square root both sides, that is the opposite to squaring. X would be equal to plus or minus the square root of 25, so x would be equal to plus or minus 5. So that is a nice equation to solve. You might even get, for example, now x cubed plus 1 is equal to 65. This is a lot more challenging. So we could subtract 1 from both sides. X cubed is equal to 64. Then take the cube root of both sides. We looked at the cube root in the previous video. This is going to give us 4. 4 cubed, let's write this in, is equal to 64. It's 4 times 4 times 4. Therefore, and I'm going to use the symbol, the cube root of 64 is equal to 4. So that's a bit tougher. I doubt that would come up. Let's just finish with one more. What I'm going to do is draw a triangle. I'm going to state now that this triangle, and we'll just do a quick sketch, let's have that. I'm going to say that this is an isosceles triangle. We can denote an isosceles triangle with these lines to say that these two sides are equal. What I'm going to do now is the following. I'm going to have now that 2x x minus 1 for this angle, and we'll have on this one, let's say this angle right here is going to be 3x minus, let's make it minus 2. So that angle is 3x minus 2, this angle is 2x minus 1, and we would just be given this problem, and it'd say find now the value of x. So what we could do at this stage, in fact, let's make this a bit more realistic, because this isn't going to be fantastic. Let's say that we're going to have, let's make this 10 and 20. Okay, so let's go ahead and solve this. So what we can say now is the following. We could say that if this is an isosceles triangle, base angles are equal. So base angles are equal. So just setting this up, we can say therefore 2x minus 10 will be equal to 3x minus 20. I'm going to subtract 2x from both sides, so minus 2x from both sides. That gives me that minus 10 is equal to 1x minus 20. I'm going to add 20 to both sides, so we can see from here, adding 20 to both sides, that x is equal to 10 degrees. So if we now wanted to find this one, this is going to now give us what we want. So that is a very poor sketch, but if x was equal to 10, then this is going to give us 10 degrees. This one right here, again, is going to give us 10 degrees. And we could state, therefore, that this angle, which quite clearly it isn't because it's not drawn accurately, would be 180 minus that, so that would be 160 degrees. So whilst my triangle is hideously inaccurate, hopefully that's given you some idea of a typical kind of question. Another typical kind of question is something along these lines. Let's say we've got 2x plus 1, and we've got now 3x, and we were asked to find now an expression for the perimeter of this rectangle. Something students forget to do often is write down that this is 2x plus 1 and this is 3x. So the perimeter now is the sum of all of the sides. So we could say, if you wanted, it's 2x plus 1 plus 3x plus another 2x plus 1 plus 3x. Or you could simply say it's 2 lots of this and 3 lots of this. So an expression for the perimeter is going to give us now 10x plus 2. That is an expression for the perimeter. An expression for the area is simply these two multiplied. So it would be 3x multiplied by 2x plus 1, which if they asked for in this form is fine. If they said go ahead and expand it, it would be 6x squared plus 3x. So that gives us a nice straightforward example. So let's say, let's just make it slightly harder. Let's move this on. Let's say they told me the perimeter was equal now to, let's make it nice and straightforward. Let's say they told us to find now the perimeter, they told us the perimeter was actually 32 meters. What we want to do is find the area. So really quite tough question. And this is very similar to the ones that we're going to look at in the functional series. So I know my expression, remember this is an expression for the perimeter, is 10x plus 2. So what we're going to have then is 10x plus 2 must be equal to 32. Subtracting 2 from both sides, 10x is equal to 30 and x is equal to 3. So I've solved this equation. What I dislike seeing students do is just go ahead and just try and work things backwards and just put numbers in. Just solve a straightforward equation and plug it in. Now at this stage I could substitute in x is 2 here. So 2 times 3 is 6 plus 1. That length right there is 6. If x is equal to 3, again this is very inaccurate, and often you'll see in the exams not drawn to scale. So not drawn, and this really isn't, as was the last one, not drawn to scale, really not drawn to scale. Okay, so now if we wanted, we could go ahead and find the area. So 9 times by 6 would give us now 60, and this would be 63, and the correct units are meters squared. Remember, area is going to be something squared. We're dealing with meters, so it's meters squared. Now, if you hadn't spotted that, you could just plug it into here. So the area is going to be 3 lots of x, well that's going to be 3 lots of 3, times by 2 lots of x plus now the 1, and that's going to give me 7. 3 times by 3 is going to give me 9. 9 times by 7 is going to give me 63. So we'd say now that the answer is 63 metres squared. So set it up. Don't revert to just guessing numbers or trying to make it work, because if they give you something nasty, you won't be able to blag it, essentially. So there we go. There's our algebra section pretty much covered. I'm fairly happy with the vast majority of the content that we've covered is what you'll need. It's certainly what I've been teaching for years and years, and it's sufficient to get you towards that top grade on the foundation paper. There might be some subtleties that we've missed out, or there might be some things, for example, like this, where we've gone just a bit beyond. But hopefully that's been of some use, and that is the end of the algebra video.